Welcome to aluminium extrusion, a key manufacturing process in producing structural components. Extrusion typically involves pushing a cylindrical billet through a die in a process known as direct extrusion. This results in sections that can be used in long lengths or cut into shorter pieces for various applications. There is also an indirect extrusion method, where the die is pushed into the billet, offering different capabilities. While the direct method is more common, both processes are crucial in manufacturing. In the direct extrusion process, a heated billet is placed in a heated container at temperatures around 450 C, 500 C. These temperatures significantly reduce the flow stress of aluminium alloys, facilitating shaping. Once the ram applies pressure to the billet, the metal flows through the die, shaped according to its design. The die defines the cross-section of the final product, influencing its properties and applications. While many alloys can be extruded, certain ones face challenges in extrudability, requiring higher pressures and potentially limiting production speeds and surface quality. This characteristic is vital for manufacturers. Multiple sections can be extruded simultaneously through the same die, increasing output efficiency. However, maintaining consistent flow speed is crucial to prevent shape distortion upon emergence. Post-extrusion, the sections undergo treatment processes like quenching or air cooling, followed by stretching and artificial aging to stabilize their properties. Common temper designations include T4, T5, and T6. The overall dimensions of a section are related to the billet diameter, and the minimum section thickness relates to the location of the section within this circumscribing circle, the complexity of the section, and the alloy. In the picture, there is that same circumscribing circle. Dimensions of the extruded sections are linked to the billet diameter, with minimum thickness defined by design complexity. Plants can produce both solid and hollow sections, but have different design philosophies for the dies. Simple hollow sections such as rounds, squares, and ovals can be produced from a hollow billet using a mandrel. Here, the product has a uniform structure across the section. More complex sections are made using bridge or porthole dies in which the metal flows around a shaped bridge and joins again by hot pressure welding in a mixing chamber. Because the deformation experienced by the welds is different from that received by other parts of the cross-section, a metallurgical examination of the cross-section reveals differences in grain structure at the welds, and if the mixing chamber design and extrusion conditions are less than optimum, the weld lines can be obvious on the section surface. Thank you for watching. If you enjoyed this video, please like, comment, and subscribe for more content. Thank you for watching. If you enjoyed this video, please like, comment, and subscribe for more content.